You know, computers are amazing at following instructions, right? You give them a list and they'll follow it perfectly. But what if we want them to do more? What if we want them to make a choice? In this explainer, we're going to pull back the curtain and see how we actually give a computer the power to decide. So how do you take a machine that's basically a super fast recipe follower and teach it to choose its own adventure? That's really the big question we're tackling, the key to unlocking truly powerful programs. All right, so here's our game plan. We'll start with this whole idea of a computer that can actually decide things. Then we'll look at the super simple language it uses for logic, the language of truth. From there, we'll build up from a basic if statement, start adding more and more options, and then see how to ask really complex questions. Finally, we'll put it all together and see the incredible power this gives you. All right, first up, computers that can decide. See, normally a program is like a straight road, but what we're talking about is adding forks in that road. The fancy term for this is flow control structures, which really just means we're telling our program, hey, based on what happens, go this way or maybe that way.
I mean, think about it. At their heart, computers just do what they're told. Conditionals, that's what gives them a little spark. It's what lets them think for themselves. It's the difference between just mindlessly following a checklist and actually evaluating a situation and making a decision.
So if a computer is going to think, what language does it use? Well, it's actually way simpler than you might guess. It all comes down to the language of truth, the absolute bedrock of every single choice a program makes.
And here's the secret sauce. Boolean values. Everything, and I mean everything, boils down to just two things: true or false, yes or no, on or off. There's no maybe, no gray area. And that absolute certainty is what makes the whole system so powerful and reliable.
Okay, so how do we get to that true or false? Well, we ask the computer questions using these things called comparison operators. We can ask, is 5 equal to 5? That's true. Is 10 greater than 20? Nope, that's false. Each one of these is a tool for asking a question that can only be answered with a true or a false.
Okay, so we know how to ask questions that get a true or false answer. Now what? Well, now we can do something with those answers, and we'll start with the most fundamental tool in the box, the simple if statement. Think of the if statement as a bouncer at a club. It checks your condition. Is it true? Cool, you're in. The code inside gets to run. Is the condition false? Sorry, you're not on the list. The program just walks right past and moves on to the next thing.
So yeah, it's basically a one-way gate. If the condition is true, we step through and run that special piece of code. If it's not, we just walk right by. We skip it completely and keep going. Super simple.
Now, that one-way gate is pretty useful, for sure. But what if doing nothing isn't an option? What if we need the computer to do one thing if a condition is true, but do something else if it's false? It's time to level up and add more options.
And this is where adding that little word else becomes a total game changer. Look at the difference. With a simple if, you're saying, hey, maybe do this or maybe do nothing. But when you add an else, you're creating a fork in the road. It's no longer optional. The program is guaranteed to go down one of two paths. It has to make a choice.
Okay, 2 choices is great, but life is usually more complicated than that, right? What if you have 3, 4, or even 10 different possibilities? That's where this structure, the if, elif, else chain, comes into play. It works exactly like a multiple choice test. The computer looks at the first if. Is that true? If yes, great. It does that one thing and then skips the rest of the entire block. But if it's false, it moves on to the next one, the elif, which is just short for else if. It keeps going down the list, one by one, until it finds the first one that's true. And if it gets all the way to the end and nothing was true, that's what the final else is for. It's the none of the above answer, the safety net.
A perfect real-world example of this is assigning letter grades. You can see it right here. It checks, is the score 90 or above? If so, it's an A and we're done. If not, okay, well, is it 80 or above? That's a B, and so on. It only executes the first one it finds that's true, which makes it super clean and prevents any confusion. So, we're getting pretty good at asking simple questions. But what if our question is more complicated? What if we need to check 2 or 3 things at the same time? Let's talk about how to build more complex questions.
First up is the AND operator. And let me tell you, AND is very strict. It's an all or nothing deal. Just look at this truth table. The only way to get a true result is if the statement on the left is true and the statement on the right is true. If even one of them is false, the whole thing comes crashing down to false.
Okay, now let's talk about OR. OR is the total opposite of AND.
It's super chill and flexible. With OR, you only need one side of the equation to be true for the whole thing to be true. As you can see from the table, the only way to get a false with OR is if both sides are false. As long as you've got at least one true in there, you're golden.
And finally, we have the not operator. This one's the easiest of the bunch. It's basically the opposite operator. It just takes whatever Boolean value you give it and flips it on its head. Not true becomes false. Not false becomes true. Simple as that.
All right, so let's take a step back. We've seen how to make simple choices, and we've learned how to combine them to ask really complex, detailed questions. Now let's talk about the real power you get when you put all these tools together.
And this is where it gets really cool. You can actually put if statements inside of other if statements. This is called nesting. It lets you create these incredibly detailed decision-making trees, where one choice leads you to a whole new set of choices.
And this isn't just some abstract programming concept, right? This is the building block for so many real-world programs. With these simple rules, you can build a program to check if a number is even or odd, or convert scores to letter grades like we saw. You can figure out if someone's old enough to vote, or even build a little app that helps you decide where to go for lunch based on how much money you have. It's all powered by this same fundamental logic.
So think about where we started. We had a computer that could only follow a list of instructions, one after the other. But now we've given it the ability to think, to make a choice, to react to different situations in different ways. And all it took were these simple building blocks, if, else, and the basic idea of true and false. With just these tools, you can now build programs that feel dynamic and intelligent. The computer can finally make decisions. So the real question is, what are you going to build with that power?